right, well, it's good to be with you this evening, and we're going to talk about worlds of creation, the solar system. There are some secular myths I feel like I need to blow up because the secular world makes these claims that, one, if you're a scientist, you certainly can't be a Christian. I mean, you can sort of go to church and have the social experience, but you certainly can't really believe it, right? Because we know from science that the universe is billions of years old, and you certainly can't believe in a literal Genesis. So those people who claim to believe in biblical creation, well, they can't do actual science. Well, that's not true, and we'll see that that's not the case this evening. And the second myth is that the universe is billions of years old and sort of exploded into existence, and then we're going to see that there are processes in the universe that can't last billions of years, a lot of them, that even if you make the secular assumptions that rates and conditions have basically been constant throughout cosmic history, they still gives you an age that's much less than the billions of years, a lot of stuff like that. And then finally, that the universe is an accident. And we're going to focus in on the solar system. The standard view of how our solar system formed is that a nebula, a cloud of hydrogen and helium gas, collapsed in on itself and rotated, and that's why all the planets orbit the same way, and they all ought to be spinning the same way, and so on. And we'll see that there are problems with that nebular collapse hypothesis. It's not consistent with the data that we'll see this evening. So this is an overhead view of the solar system. It's what you would see if you were above the North Pole of the sun, sort of looking down on it from several hundred million miles away. And this, by the way, is the current positions of the planets, in case you were curious. That's where they are right now. That's kind of neat that we can do that and simulate that. And I have to point out that the nature of our planets, the way they orbit the sun, that was deduced by a biblical creationist, a devout Christian named Johannes Kepler. He was a Christian, lived in the late 1500s, early 1600s, and he was able to figure out that planets orbit the sun in ellipses rather than perfect circles. Actually, at that time, there was debate as to whether the planets orbited the sun at all. Many people thought the planets and the sun all orbited the Earth. That's the geocentric view, and it's not true. But Kepler figured out that no, the planets orbit the sun, and they orbit in ellipses with the sun at one focus of the ellipse. And if you wanted to draw an ellipse, you could take two thumbtacks and stick them in cardboard, take a piece of string and tie it to itself so it makes a loop just a little bit bigger than the distance between the two thumbtacks, and then loop it over those, and take your pencil and pull it so it's taut, and then roll it around like that. That'll make an ellipse. And the thumbtacks are each one is a focus, or foci, the plural of that. So the sun is at one focus, the other focus is empty. Kepler didn't know why they behaved that way, but he figured out that they did. And you can see that with the planet Mercury. You can see that it's a little closer to the sun there because it's close to that focus, and then it's a little further away from the sun when it's around there. So the orbit's a little bit squashed. It's not a perfect circle. Now, they're only slightly elliptical, but orbits have to be, by their nature, ellipses, remembering that a circle is a special case of an ellipse. And with comets, they can be really squashed. But in any case, Kepler figured that out, and he figured out that planets sweep equal areas in equal times. Basically, when a planet is closer to the sun in its orbit, it goes a little quicker, and when it's farther away, it slows down a little bit. And he was able to figure out the exact mathematical formula there. You can see that with Mercury a little bit. When it's closer to the sun, it speeds up just a little bit. When it's farther away, it's a little bit slower. If I were to do this with comets, it would be really obvious. They really whiplash around the sun, and then they get really slow when they're far away. But the planet orbits are close to circles, and so the speed up is not as noticeable. And then finally, Kepler discovered the relationship between the period of a planet and its distance from the sun, its average distance from the sun. He figured out that the period squared is equal to the distance cubed. P squared equals A cubed, where the period is in years and the distance is in AUs, where 1 AU is the Earth distance to the sun. And so that's pretty neat that he figured that all out. So you can see how Mercury completes a loop much faster than the Earth. Mercury takes only 88 days to orbit the sun once. Earth takes a year. That's where we get the idea of a year. We define it that way. Mars is about a year and a half, and so on. The outer planets are much slower. And you might say, I think I could see that they're not perfect circles with Mercury there. I can see it's a little bit elliptical. I think I could have figured that out. And I think I can see that they do speed up a little bit when they're closer to the sun, and given enough time, I might even be able to figure out their period squared is equal to their distance cubed. With a program like this, which Kepler did not have. Kepler had a list of numbers recorded by Tycho Brahe, also a Christian. Yeah. And they didn't even have telescopes yet. Tycho Brahe recorded the positions of Mars as it appears in Earth's sky. And from those numbers, Kepler was able to figure out the information I just presented to you. Consider how hard that is, considering we're on one of these planets, orbiting the sun, watching another planet orbit the sun. You have to solve two math problems simultaneously, Earth's orbit and Mars's orbit. The guy was brilliant. Okay, so he's no slouch. And the fact that he was able to figure that out tells you, yeah, Christians, they're not stupid. They're not. Most of the founding fathers of the various disciplines of science were Christians. And that's certainly true in astronomy with Johannes Kepler. And based on the data from Tycho Brahe, both Christians. Now, Kepler did not know why planets orbited that way. It would take another biblical creationist named Isaac Newton to figure that out. Now, we don't want to mischaracterize people. Everybody has their words. Isaac Newton may have had he certainly had a nuanced view of the Trinity. He may not have even accepted the Trinity. I'm not sure. But in any case, he did have a lot of respect for the Bible and thought that he would be remembered for his teachings on the Bible rather than his scientific discoveries, which is interesting because they are numerous. Newton figured out that the reason planets orbit this way is because of gravity. The sun has a gravitational pull. It pulls on planets. And if a planet was stationary, it would just fall right into the sun. All of them would. But God imparted planets, when he created them, with a sideways motion so that if the sun weren't there, they would just move in a straight line. The sun's gravity pulls that line into an ellipse. And so planets fall, but they don't fall toward the sun. They fall around the sun. That's what an orbit is. It's the same reason the moon orbits the earth, because the story, according to Newton, is he saw an apple fall, and then I imagine he's looking up at the moon. Why doesn't the moon fall? The moon must fall. But why doesn't it fall to the earth? Oh, and he realized it has enough sideways motion that by the time it's fallen 3 feet, it's moved away a number of feet that its distance remains about the same on average. Pretty clever guy. The math at the time did not exist to be able to prove that, so Isaac Newton invented the math we know as calculus to be able to solve that problem. Smart guy. Biblical creationist, had tremendous respect for the Bible. He was not an atheist. The modern mantra is, well, atheists, they're the really smart people that understand science. That would have been a shock to folks like Kepler and Newton. Anyway, as we get out to the outer planets, they are much further away from the sun. People don't realize how much further. And they barely move compared to the inner planets. We have to really speed up time, which I can do. Get the inner planets really zipping around there. It's fun to see, isn't it? And then Jupiter takes, about 12 years to orbit the sun. Saturn takes 29 years to orbit the sun once. The outer planet's much slower. Pluto, 249 years to orbit the sun once. So it hasn't orbited since it was discovered back in 1930. So, by the way, Pluto's still there. It's just not a planet anymore. But it's still doing what God created it to do. The planets all orbit in approximately the same plane. That's interesting. That's a design feature, I think, because if the planets are pretty big and the solar system, it's big, but the planets are big enough, there's not a whole lot of space available compared to the distance between planets. If they were in haphazard orbits, one planet could come close to another, and over time, its gravity could perturb the other planet and kick it out of the solar system. So God organized them by putting them in the same plane, and they orbit in the same direction as well. Now, once you get farther away from the planets, then stuff can orbit in a different pattern, and it's fine because there's so much space available that the chances of a gravitational perturbation are very small. So that is a design feature. But I have to tell you, secularists have a way of explaining that too, because they would say, but the solar system formed from a cloud that collapsed in on itself, a nebula, and that's why they all orbit in the same plane in the same direction. So they also have a reason for that. You'll find that a lot of things in astronomy, there's two ways to look at it. And it's not obvious just from the data itself which one's wrong. Well, not until we look at some of the details anyway. Sometimes in textbooks you'll see a perspective view of the solar system where it's kind of a little bit tilted like that. And sometimes people have the misimpression that the orbits are really elliptical. They're not. They're slightly elliptical. That's just a perspective view. An overhead view shows they're pretty close to circular, but not quite. So we'll go back to the inner solar system here. Now, we live in an amazing time because we've actually sent spacecraft to all the planets of our solar system. And a lot of their moons have been visited by spacecraft. Yeah, that's amazing. And so we have close-up pictures of these things, and they're so cool. It just shows you God's creativity and his glory in what he's built into this solar system. So that's something I'd like to share with you as we explore these worlds. Now, this is a simulation, of course, but it's based on real pictures, real images that have been reported back from these unmanned spacecraft that we've sent into space. And so what you're going to see tonight, that's the way it would look if you were there. It's all based on real images that we've extrapolated and then remapped onto spheres so we can look at it from different angles and such. And we'll start with the sun. We have to start with the sun. It's 99.98% the mass of the solar system. Most of the solar system is the sun, so there it is. And it's a ball of hydrogen gas held together by its own gravity. Yes, gas has gravity, and you get enough of it, it'll stay together. Once you get it together, it'll stay together. Now, getting gas to come together like that is problematic. Secularists believe that clouds just nebula, these clouds of gas, hydrogen, helium gas, just collapse in on themselves. But normally the nebula is so big that the force of gravity is very meager, and the outward gas pressure is much greater than the meager inward force of gravity. So it wouldn't start to collapse. Now, once a star is made, its gravity will keep it together because the force of gravity is inversely proportional to the square of the distance, which basically means if things are close together, gravity's strong. If they're far apart, gravity's weak. So once you get the gas together, it'll stay together. But making a star, I'm pretty well convinced only God can do that. It's not something that would happen naturally. Secularists have to assume that stars form naturally because there's hundreds of billions of them. And that's just in our galaxy. And so the assumption is, we don't think God did it, therefore they just happen from time to time. But I'm very skeptical of that. So that's what the sun looks like. At the surface, it's about 6,000 degrees Celsius. It's powered by nuclear fusion in the core. The sun gets hotter as you go in because it is a ball of gas. And as you go in deeper and deeper, at the core, it's about 15 million degrees Celsius. And that's hot enough that the hydrogen atoms get banged together to where the nuclei can eventually form a helium atom. And I won't go into the details of that, but the point is it releases energy, and that energy trickles to the surface. See, the sun's surface is emitting energy into space, but what keeps it from cooling off? More energy is supplied from the core. Pretty neat. And the sun releases more energy in 1 second than 1 billion cities on Earth could use in an entire year. And so it just gives you a little taste of God's power that he spoke that into existence on day 4 to be a light for the earth. I think that's amazing because God could have made like a light bulb for the earth, but instead he made that. That's 100 Earths across. That's how big it is. And if you say, yeah, but it looks tiny, I can cover up the sun with my finger at arm's length. That's because it's 93 million miles away. And it's pretty interesting how we learned that stuff using geometry and math, and it's just really neat what the Lord's allowed us to discover over the ages. You might notice that there are some dark spots on the sun. We call those sunspots because we're not very creative, and it's at least descriptive. Those are cooler regions on the sun where a magnetic field has penetrated the surface, and that prevents convection. It basically cuts off the power source, and they cool off to a chilly 4,000 degrees Celsius. So they're still hot, and they're still glowing. It's just they glow less than the rest of the sun, and so by contrast, they appear black. But you could drop a couple Earths right into that sunspot that you see on the left there. That's how big they are. Pretty magnificent. So that is the sun. One of the problems with the secular view of the sun, it's called the faint young sun paradox. And it has to do with the fact that as the hydrogen in the core gradually is depleted because it's turned into helium, the core should contract. It should cause the sun, ironically, to actually get brighter over time, which means if you run it backwards in the past 3 billion years, the sun would be about 30% fainter than it is today, 30% less energy. The Earth couldn't survive with that much less energy, right? And if anything, the paleontology seems to reveal that the Earth was warmer in the past, if anything. So it's a problem if you believe the Earth and sun are billions of years old, but it's not a problem for biblical creation because over 6,000 years, the change is negligible. So that is the sun. And we've sent a number of spacecraft that have orbited around the sun. I used the SOHO spacecraft in my doctoral research, and it's designed specifically to look at the sun. And we had some spectacular views of it. So I've seen more images of the sun than I care to report, to be honest. The first planet out from the sun, Mercury, it's about a third the size of the Earth and looks kind of like the moon. It's just a rocky little planet there. Again, a third the size of the Earth and 3 times closer to the sun. Makes that easy to remember. And so there's Mercury. It's the fastest orbit around the sun, only 88 days, but it turns very slowly. It takes 58 days for it to turn once. And so it would have a very slow, you'd have a very slow sunrise, let's put it that way. But that would be the least of your problems because it has no atmosphere, so you can't breathe. And that's probably one of the reasons it looks the way that it does. It's got all those craters on the surface because anything that, there's lots of other stuff. There's asteroids that orbit, even at that distance. And if they come too close to Mercury, boom, they hit the surface. There's no atmosphere to burn them up. So they leave a nice little crater there. So it's just covered with craters. It's accumulated quite a lot in 6,000 years. And God may have used process when he made the worlds on day 4 too. And some of those craters could be the leftover process that God used. We don't know the details of that. In any case, that's what Mercury looks like. And because it has no atmosphere and because the day side faces the sun for weeks at a time, it reaches a surface temperature of 800 degrees Fahrenheit on the day side. The night side, on the other hand, has not seen the sun for weeks, and there's no atmosphere to trap the heat in, so it drops to like negative 200 degrees Fahrenheit, if not more. So it's a planet of extremes. Now, given that the day side is extremely hot and the night side is extremely cool, there would have to be a spot where the temperature's kind of comfortable, right around there. So if you're going to crash land on Mercury, you want to aim right about there, okay? A little before sunrise or a little after sunset. And then it turns out that Mercury rotates slowly enough that if you did crash there and started running west, you could outrun sunrise. Isn't that wild? You don't dare stop, though, or it rotates around and you get vaporized, so that's not good. But now you know what to do if you crash land on Mercury. So there you go. You heard it here. So that's Mercury. One of the things that was surprising about Mercury, at least from a secular perspective, is that it has a magnetic field. And that's surprising because magnetic fields naturally decay over time. We've measured Earth's magnetic field. It's decaying. Over the last century and a half, it's been decaying. And we'd expect that. Magnetic fields are caused by electrical current in a planet's core. And then that electrical current encounters resistance. And so it decays over time. Batteries run down. That's what the magnetic field is. It's like a battery. Now, Mercury is a small planet, though. It's only a third the size of the Earth. And so just as you'd expect, it's a smaller battery. They don't last as long. Just like the little AAA batteries, those don't last very long, right? But remember those big D cells that you used to use? I mean, they lasted forever because they're bigger. They can hold more charge. And so a little planet like Mercury to still have a magnetic field, and that's been confirmed by the 2 spacecraft that have flown past this planet. It does have a magnetic field. That was surprising to the secularists, but not surprising if it's about 6,000 years old. So there's just one of many phenomena like that confirm the biblical age of this little world. So pretty neat. So Mercury, basically a big rock in space, a bit bigger than the moon, but otherwise very similar. Now the next planet out is Venus, and it's been called Earth's sister planet because it's about the same size as the Earth, but that's where the similarity ends. Because that and it's a rocky planet like the Earth is, but it's completely enshrouded in clouds. And some secularists in the past speculated that Venus might have all kinds of exotic life on the surface, and they were free to speculate, unfettered by inconvenient data because of those thick clouds. You can never see the surface of Venus. So they thought, it might be civilizations, all kinds, or at least a tropical paradise. That was before they learned the surface temperature is 900 degrees Fahrenheit. Not going to have life on Venus. It's even hotter than Mercury, even though it's further away, because of that thick atmosphere. It's 90 times thicker than Earth's atmosphere and made up almost entirely of carbon dioxide, which is a mild greenhouse gas, but you get enough of it, it's a pretty good greenhouse gas. And those clouds are made up of sulfuric acid type compounds. So it's just a nasty place. And If this, I mean, the surface, just the atmospheric pressure would crush you like a tin can unless you vaporized first from the 900 degrees Fahrenheit or unless you were dissolved by the sulfuric acid in the clouds. There's just lots of ways to die on Venus. It is not a vacation spot. And some people have said, well, why did God make a planet like that with a toxic atmosphere and surface temperature that would kill you? Well, you're not supposed to go there, right? He made Earth to be inhabited, not Venus. And that thick atmosphere makes Venus one of the most beautiful objects in our sky. It's the evening star. Maybe a couple months ago you saw it in the evening. That was Venus. It's in the morning sky now. So really beautiful. By the way, we can penetrate that atmosphere now because we sent a spacecraft to Venus called the Magellan spacecraft, and it went into orbit around Venus and used radar to map the surface. Radar can go through clouds. And so we now know the surface looks like that. That's the surface of Venus. It is just it's got an eerie beauty to it, but it's just a nasty place. You can tell, yeah, I don't want to live there. I do not want to live there. You might have noticed this, that Venus rotates backwards, the opposite of the other planets. So the sun would rise in the west on Venus and set in the east, the opposite of Earth. So it's rotating, if you're looking over the North Pole, it would be clockwise, whereas Earth is counterclockwise, looking over the North Pole. And that's interesting because if the solar system had condensed from a nebula, everything really ought to be spinning the same way due to a principle called conservation of angular momentum. And all the planets do orbit the same way, but and Earth's spinning the same way it orbits, but Venus is exactly the opposite. And that's very difficult to explain, and I wonder if God did it that way just to confuse the secularists. Because God has made all kinds of interesting worlds out there. And Venus is one of them. And it's spinning just the opposite of the way the secularists would expect. And there's all kinds of problems. Most of them believe that it formed spinning the same way as the other planets and then something hit it. I've done some calculations on that. It's very hard to do that. The amount of energy required to get something, to get a planet to spin the other way, very, very tricky. So I think that's not feasible in my opinion. So that's the second planet from the sun, Venus. The third planet from the sun, my very favorite, is Earth. It has the most restaurants of any planet. It's the planet that God formed to be inhabited and has all kinds of wonderful life-affirming features on it due to the way that it was created. And just a beautiful world. And I feel very privileged that we have now seen our planet from above. Now, this is a simulation, but it's based on actual images that we've taken. A friend of mine is an astronaut, and when he has downtime, he goes to the lower portion of the International Space Station and takes pictures of the Earth from space, and they're stunning, absolutely beautiful. And what a beautiful planet we have. Covered with liquid water, 71% covered with water, and water is, we believe, necessary for life. All the life that God created, as far as we know, requires liquid water because it's a great solvent, and so you can put all kinds of chemicals in there and get them to coordinate and so on. And so it's a beautiful world. I have to point out the water molecule is pretty common in the universe, H2O, but it's almost always either vapor or ice. To have it in a liquid state, you have to have the right kind of temperature range and you have to have sufficient atmospheric pressure. And as far as we know, only Earth has that. It wouldn't surprise me if they found another place in space where there was liquid water, but my point is Earth's covered with it and it has free oxygen in the atmosphere, and that's very unusual. We're going to find no other planet has that. So Earth's the only place you can breathe. So it's our home. It's designed for life. It's tilted about 23.5 degrees, and that's what causes seasons. Seasons are due to Earth's tilt as it orbits around the sun, and when the northern hemisphere is tilted toward the sun, we have more daylight hours, and the sun is higher in the sky, so you get more direct sunlight, warmer temperatures, and then in the winter, the Earth's on the other side of the sun, the northern hemisphere is tilted away, and so we have fewer daylight hours, and the sun is lower in the sky, you get less direct sunlight, and so the temperatures are cooler. Earth has polar ice caps. Of course, Antarctica, you can see there. And then it has a northern polar ice cap, which there's no land there, but it still grows in the winter and shrinks in the summer. That's pretty neat. That's not unique to Earth, we'll see, but it is interesting. Earth has plate tectonics, meaning the Earth is divided, its crust is divided into plates that under the right conditions can be moved. And we think that's the mechanism that God used to start and end the flood. We think plate tectonics was the mechanism he used. There's a lot of good science. It's not, the Bible doesn't directly state that, but there's a lot of good science that confirms that. We think the Earth's original surface looked a little different. We think the continents were connected, looking something like that. There's some debate about exactly the shape, but something like that before the worldwide flood. And then we think they were pushed apart during the flood when the fountains of the great deep burst forth, reference to underwater volcanoes perhaps, and tectonic activity that resulted on the surface. Earth has a magnetic field. One of the things that I want you to remember about magnetic fields is they do not last billions of years. We know that with Earth's magnetic field, it has been decaying. It's been losing energy for the last 150 years. We've been able to measure it. It appears to be an exponential decay. So you run it back in time, and it would have been very strong in the past. You run it back to creation, 20 times stronger than it is today. And that is a life feature. Now, some other planets have magnetic fields too, but Earth's is just right to deflect cosmic rays, but not so strong as to rip iron out of your blood, for example, okay? Jupiter's a different story, but in any case. So with that magnetic field protects life on Earth because cosmic rays, which stream from space, they're dangerous to life. We don't know exactly what causes them. There's different theories on that. But, and a few of them make it to the surface, but very few because Earth's magnetic field acts like an invisible shield and deflects them harmlessly back into space. If they intersect your DNA, they can cause mutations, and you don't want that. Mutations do not give you superpowers like in the movies. They give you cancer. So yeah, you don't want mutations, okay? So Earth has all these life features, mountains and valleys and canyons, and it's ideally suited for life at the right distance from the sun so that water can be in a liquid state so that we can have life. And tilted, and that's a design feature too. Earth's tilt not only causes seasons, but it maximizes Earth's habitable zones. If the Earth were less tilted, you'd have less, the seasons would be less extreme, but the Earth's habitable range, the equator would become too hot, the poles would be colder, it would reduce habitable zones. If you tilt the Earth more, the seasons become extreme, and so you might not survive the summer or the winter. So it's ideally tilted for life, which is neat. Earth has a large moon, which we call the moon. There it is. Let me rotate it around here a little bit. There we go. And you understand, before the year 1610, this was the only moon we knew of. Most people, it had not even occurred to them that other planets could have moons. We take that for granted now. But in 1610, Galileo pointed his telescope at Jupiter and realized it too has moons. That was the first time anybody had done that. So that's why we just call it the moon. But the moon is designed for life on Earth because it stirs up, oh, there's a little lunar eclipse. Did you see that? Back it up. There it is. So occasionally the moon goes directly into Earth's shadow. Earth casts its shadow on the moon. It casts a circular shadow because the Earth is round. It's not flat. I've seen lunar eclipses. But the moon stirs up Earth's oceans, and that keeps them from stagnating, and that keeps the diatoms producing oxygen. It's a life feature. So isn't that neat? That's one of the purposes of the moon, and it helps us keep time. It's where we get months from. A month is a moonth. It's the amount of time it takes the moon to go through its phases. We've defined time a little differently in our calendar today than the Hebrews did, but that's the basic idea. Now you might notice you always see the same side of the moon. And so there's this feature that people look for. Sometimes it looks like the man in the moon, or some people see a rabbit or whatever. It depends more on your psychology than anything on the moon, but like an ink blot test. But the moon does rotate. People, why doesn't it rotate? It does rotate. It just rotates at the same rate it revolves around the Earth. So we always see the same side. If it didn't rotate, eventually, half a month later, you'd see the other side. But it does rotate. And if you were to watch the moon from distant space, you could see it rotating, and you could see the far side looks very different from the near side. The near side has all those large dark areas called maria. The far side has very few of those. Maria, it's from the Latin word meaning seas, because they used to think they were seas, that they were oceans on the moon. They're not. They're basalt, areas that were once magma, and that's why they're very flat, because it was liquid at one point, and then it hardened to be rock. So there's a beautiful simulation of the moon with the Earth behind it. Amazing. 12 people to date have walked on the moon, and I think that's amazing. Can you imagine that, standing on the surface of the moon, looking up and seeing the Earth as this little marble there, knowing everyone you've ever known or loved is on that little world except your buddy here. I mean, it's just amazing. We're going back with the Artemis program. I hope that's successful. I'd love to see that. I was just a little too young for the previous moon landing. So the moon has what's called remnant magnetism. And remnant magnetism basically means that if you were to hold a compass close to the rocks on the moon, it would point in a different direction depending on where you're at. Point this way, you move to the next rock, points that way. You move to the next rock, points that way. Like little bits of magnetic field. And that indicates that the moon once had a global magnetic field like the Earth does with the North and South Pole, but it's decayed away, even in 6,000 years, because the moon is small. It's only a fourth the size of the Earth. And in 6,000 years, the magnetic field has dropped to zero, basically, other than that little bit of remnant magnetism. But even remnant magnetism can't last billions of years. And so that's an indication that the moon can't be billions of years old. So Earth's magnetic field and the moon's magnetic field, both are indications that they are thousands of years old and not millions, let alone billions. They just don't last that long. So beautiful world, and again, I feel very privileged that we've seen our planet from space. Really quite a privilege, something our ancestors only could have imagined. The next planet out is Mars, the red planet, and it is red. It's made up of iron-type compounds, and those compounds, there's a better map of it, those compounds, basically like rust. Iron, and they get oxidized, and that's what forms the surface of Mars, basically rust, different forms of it. A lot of interesting features on Mars. It is fun to look at in a small telescope, but normally it doesn't look all that impressive except every 2.1 years when the Earth passes it, because Mars is only half the size of the Earth. And so it normally looks really small in a telescope, except every 2.1 years when Earth passes it, and it looks really big. And by the way, some passes are better than others. One of the things I always look for, this big dark feature right here, you can almost always see that. It's called Syrtis Major. You can almost always see it when Mars is rotated so that it's facing us. And then there's this big valley down here called Hellas that often fills in with fog and looks very bright. People mistake it for the southern polar ice cap, but it's not. That's a little further down. So anyway, let me change the time here so we can see. I wanted to show you it has polar ice caps like Earth does. There's the northern polar ice cap of Mars. But unlike Earth's polar ice caps, which are made of water ice, these are primarily frozen carbon dioxide, dry ice. So even the carbon dioxide freezes on Mars under the right conditions. And then there's carbon dioxide in its atmosphere. It's got a thin atmosphere. So there you go. That's the northern polar ice cap. Because it's tilted about the same as the Earth is. And so it would have seasons just like the Earth. But they're 50% longer because its year's 50% longer. So they'd last a little longer. Mars has Earth-like features like canyons. In fact, here's an enormous canyon right here. You see that big scratch mark? That's a massive canyon called Valles Marineris. It's bigger than Earth's Grand Canyon. In fact, the length of that would cover about the United States. It's a massive canyon. But unlike Earth's Grand Canyon, which is formed by water, probably the runoff from the flood, this is a tectonic fissure where the surface is broken apart. Now, Mars doesn't have plate tectonics. No planet other than Earth does, as far as we know. But it does have geology. It has tectonics. And so its crust broke open at one point and formed that tectonic fissure. Quite stunning. Mars has mountains as well. You can see several of them right here. See these big, look like large bumps? Those are mountains, volcanic mountains. There's a really big one right here. This one's called Olympus Mons. This is the largest known volcano. It is 3 times taller than Mount Everest. And the base of it would cover the entire state of Iowa. So it's a very shallow sloping volcano. It's what we call a shield volcano. As far as we know, they're extinct, but they might just be dormant. A friend of mine, Ron Samek, thinks that they might still be active, and I think he's probably right. From a secular view, Mars should have lost all of its internal energy billions of years ago. And so you can't have volcanoes today, active volcanoes. But 6,000 years, it might still have internal heat. And so my prediction is we might see these volcanoes go off in the near future. And that would be a confirmation of biblical creation. And you heard it here first, okay? If it happens, you heard it here first. So there you go. So keep that in mind. So yeah, so there's Mars. Real thin atmosphere of carbon dioxide, so you can't breathe on Mars. No liquid water on the surface today. In fact, the atmosphere is too thin to support liquid water. You need atmospheric pressure to have, you know how if you go higher up on a mountain, water boils at a lower temperature, right? Well, on Mars, it boils at 0. It goes directly from ice to vapor. There's no liquid state, like dry ice does on Earth. So Mars can't have liquid water today, but we know it once did because we find dried up riverbeds on Mars. And there are lots of them. And deltas where the rivers deposited the material, and they're obvious. I've seen them. They're pretty neat. And Ron Samek has a neat model for that. He thinks when volcanoes go off on Mars, they temporarily increase the atmospheric pressure to the point where you can have liquid water, rainfall. I think that's a pretty good model. Mars has 2 moons, and they are tiny. They're called Phobos and Deimos. The names mean fear and terror, because Mars is the god of war, so fear and terror accompany war. And the surprising thing about Deimos to many people is that it's not round. Small moons don't have to be round. Large moons have to be round because their gravity will pull them into a spherical shape. If they weren't to begin with, the gravity would cause them to fall that way. But this is less than 10 miles across, and it looks like a big potato in space. So there it is. So that's Deimos. That's the outer of the 2 moons of Mars. And you can see these in a backyard telescope. You need a pretty good one, and Mars has to be at its closest point to the Earth. And even then, they're tricky to see. But I have seen both of Mars's moons. And the inner one is Phobos. Phobos is about 10 miles across on its largest axis. It's just slightly larger than Deimos. And it's fun to watch it orbit because it takes only a few hours to orbit. I remember going out and seeing Mars one night, and Phobos is on the right side. And then I came back a few hours later, and it's on the other side of Mars. It just orbits that. A few things in space are that fast. So it's fun to see. If you were on Phobos, Mars would look enormous in your sky because it orbits very close to the planet. And that would be a spectacular view. But, being only 10 miles or so in diameter, if you can call it a diameter, because it's not spherical, you can hike around that moon. That'd be a nice little hike. That's kind of neat. And the gravity is very weak because it's so small. In fact, you could pick up a rock and throw it into orbit. You could watch the rock go over the horizon, and you could watch it come up over this horizon, catch it, and throw it that way. Isn't that neat? You play catch with yourself on Phobos. So I think that's neat, these situations that just can't occur on Earth, but they occur out in space. Mars, like the moon, has remnant magnetism. That's an indication that it once had a dipole magnetic field, but in 6,000 years it's decayed away. But it also indicates that it can't be billions of years old because that magnetic field would be dead by now. So it's an indication that Mars is young and nowhere near the 4.5 billion years that the secularists allege for the age of our solar system. Now, all these planets we've looked at, Mercury, Venus, Earth, and Mars, are called terrestrial planets, meaning Earth-like, because they're like the Earth in the sense that they're rocky. They're made up of rock. You could land on them, theoretically. With Venus, you couldn't land very long. You're going to be incinerated. But with the other ones, you could land on them. And they're solid. The outer planets are not. Jupiter is a ball of gas. So you can't land on Jupiter. There's nothing solid to land on. The gas gets thicker as you go in. It probably becomes liquid at some point. We're confident of that. We don't know if the transition is sudden or gradual, but there's nothing solid to land on there. It might have a rocky core, but that's speculation. But because it's a ball of gas, it has these interesting features that form on it, these large stripes that you always see. You're seeing clouds on Jupiter, but Jupiter's made up of interesting compounds, not just water vapor, but other compounds like methane and ammonia, and you get these beautiful colors, a lot of orange, and then some white, little bits of blue. They're a little harder to see. But you can almost always see those 2 stripes right there. These are called the equatorial belts on Jupiter. Even in a small telescope, you can see those, almost always. Every 10 or 20 years or so, the southern belt disappears for a few months. We're not sure why that happens, but it's interesting. I have seen that happen. And then Jupiter looks weird without the southern belt for a few months, and it comes back. Those are basically jet streams. Earth has jet streams. You get the northern, and then you get the mid-latitude, and then the equatorial, where the winds go in a particular direction. Earth's are transparent, though. Our sky is mostly transparent, other than some white clouds. But with Jupiter, you can see. By the way, you can see the shadow of one of the moons there, falling on Jupiter. You can watch that in a small telescope too. It takes about an hour for it to go across. It's neat. But with Jupiter, the jet zones are visible. The jet streams are visible, and there's more of them because it's a bigger planet. Jupiter's about 10 Earths across, so an enormous planet. One of the really interesting features on Jupiter is this great red spot, which astronomers call the Great Red Spot. And it's basically an enormous Anti-hurricane. A hurricane's a low-pressure system. That's a high-pressure system. It's a big storm on Jupiter. Now, hurricanes are powered by heat from the ocean. In fact, after a hurricane goes past the ocean, the temperature drops about 10 degrees. It's powered by thermal energy. And so hurricanes on Earth move over the land eventually, and then they get cut off from their power source, and they peter out. They're gone. Jupiter has no land. So that hurricane has been going for at least 300 years since we've had telescopes powerful enough to see it. It might have been there since creation, we don't really know, but at least 300 years. It changes color, it moves a little bit. It doesn't move up and down because it's sandwiched in between the southern equatorial belt and then the zone just below it. The belts are dark, the zones are light, so it gets sandwiched there and rotates. But it can move left and right. And so you can't predict where it will be real far in the future. You can for the next few weeks. You can look it up on a website and see when the red spot will be centered. And that's the best time to look at it, when it's dead center. Because when it's off to the side, it's hard to see in its small telescope because you don't have the clarity that you have here with this simulation. And the shadows of the moons are predictable too. I mean, this is all predictable thanks to Johannes Kepler, that wonderful Christian who figured out the way things move in space. Jupiter's moons obey Kepler's laws as well, and so we can figure out when they are going to transit, when they're going to cast their shadow on Jupiter. That's all predictable in advance. Jupiter has a very strong magnetic field, much stronger than the Earth's. Jupiter's magnetic field would be larger than the sun if you could see it. It's massive. And that's an indication that Jupiter cannot be billions of years old because those magnetic fields decay with time. Also, Jupiter has internal heat, meaning it radiates more energy into space than it receives from the sun by about a factor of 2. So it gets 1 unit from the sun, gives away 2. It gets 1 unit, spends away 2. It's kind of like our federal government, right? Yeah. And like our federal government, it can't do that forever because eventually you run out of heat. And if Jupiter really were billions of years old, it shouldn't have any internal heat left. It's a really big issue for the secularists. It's not a problem if you think it's 6,000 years old, because Jupiter's big. It's 10 Earths across. It's a big planet. And in 6,000 years, it can maintain that thermal energy. The analogy would be like a potato that you've just taken out of the microwave. You can feel the heat coming off of it, right? That's radiative transfer. If you come back 2 hours later, you still feel the heat coming off of it? No, it's cold, right? Now, Jupiter's a much bigger potato, and so it can do that for 6,000 years and still be radiating. But it can't do it for 4.5 billion years. And it's always interesting to look for the secular explanations for that, and I haven't seen one that really makes a lot of sense. Anyway, so Jupiter has 2 indications that it can't be anywhere near billions of years old: that strong magnetic field and the excess internal heat. So very interesting. Jupiter has a lot of moons, over 90. Yeah. And to be honest, I've lost track because they keep discovering more. And so Jupiter and Saturn kind of go back and forth on which has the most moons because they keep discovering more. And one of the 2 of them's up over 100. I think it's Saturn that's up over 100 now. But anyway, I lose track. 4 of them are big. And these were the ones that Galileo saw in the year 1610. The telescope was invented in 1608. Galileo had heard that it had been done, that Hans Lippershey had invented this instrument that by a combination of lenses, you could make things look much bigger than they really are, as if they're closer. That's all he knew. And back then, if you wanted a telescope, you had to build it. There was no Walmart where you could get your telescope, right? By the way, don't get a telescope from Walmart. Just saying. Okay. There are better places. But anyway, Galileo, because he was wealthy and had nothing better to do, he spent his time grinding lenses. You had to make your own lenses then too, which he could do. He was wealthy. And by 1610, he had designed a pretty good telescope for his day. Binoculars today would be better than Galileo's telescope probably. But for his day, it was good. And he pointed it at Jupiter, and he saw 4 little starlets lined up with Jupiter. And he thought, that's peculiar. Why would they be lined up like that? What an amazing coincidence. And then the next night when he went out, because Jupiter moves, it's a planet, it's orbiting the sun, he thought those were background stars and Jupiter would leave them behind. But the next night, they caught up with Jupiter, and one of them got ahead of it. How did that happen? And night after night, he noticed they circle around Jupiter, and they're in a straight line because Jupiter is edge-on relative to us. It's the one planet that is the way secularists think all of them should be. It's upright and spins in the right direction. And so the moons do that too. They orbit around Jupiter's equator. They're always in a straight line. And you can see those in a small telescope to this day. You go out on a clear night, point your telescope at Jupiter, you'll see 4 little starlets, unless one of them is directly behind or in front of Jupiter. Then you won't see it. That happens sometimes. So anyway, let's take a look at these. To Galileo, they just look like little stars. Today we call them the Galilean moons in honor of Galileo. And we have close-up images of them now. Thanks to the Voyager spacecraft and the Galileo spacecraft that flew. Galileo went into orbit around Jupiter. Voyager 1 and 2 flew past it and took wonderful images of these moons. And they're awesome. And they declare God's glory and his creativity. So the innermost of the big 4 is called Io, or Io. I love it, because it looks like a pizza. Isn't that awesome? Either that or an orange that you forgot you left in the refrigerator, and it kind of, yeah. Isn't that wild? Nothing looks like that. It's so colorful. And that's based on sulfur compounds. It's different varieties of sulfur interacting with other minerals. If you've ever been to the Yellowstone National Park, the geyser area, it looks similar to that for the same reason. It's the same chemistry. So, and if you've been to that area, you know it smells awful. It smells like rotten eggs. So would Io. But you won't see impact craters on Io, places where asteroids have hit it, and that's unusual. Io and Earth are the only 2 bodies, solid bodies in the solar system where you don't see massive amounts of craters. And there's a reason for that. For Earth, it's because we have a protective atmosphere and we've got plate tectonics and environmental processes that tend to erode craters. We do have a few. With Io, it's because it's been completely resurfaced by volcanic activity. This is the most volcanically active world in the solar system. When Voyager 2 flew past Io in 1980, it discovered 9 volcanoes going off at the same time. In fact, the little bumps that you see on there, those are volcanoes, all of them. And they're going off constantly. It's amazing. And so that indicates that Io has internal energy, internal heat, and therefore the natural conclusion would be it can't be billions of years old. I have to point out, secularists have invoked an explanation. They've said it's because it orbits so close to Jupiter and the next moon out that it gets a tidal tug every time it lines up between Jupiter and the next moon out, Europa, and that tidal friction stimulates internal heat. I don't know if that'll last billions of years, but I just wanted to point out they do have an explanation for it. But it's also consistent with thousands of years. That works too. Io is about the same size as Earth's moon, just very slightly larger, but otherwise very similar. Icy world. The next moon out, Europa, is the smallest of the big 4, and it is an icy moon. The farther out you get into the solar system, the less stuff tends to be made of rock and the more it tends to be made of ice. So there's Europa. One of the interesting things about Europa, it has these huge scratch marks on one side, like a big cosmic cat came and just kind of swiped it. And we think those are probably geysers where water vapor has been spewed up into the atmosphere, because it does have the water compound, the water ice on it, so that could be an explanation for that. So there's little Europa, just slightly smaller than Earth's moon. The next moon out is Ganymede. It's the largest moon in the solar system. Fitting that it orbits the largest planet, Jupiter. So there's Ganymede. Very beautiful, very colorful, kind of got a tri-color surface, a dark brown, a lighter brown, and then these beautiful white craters where the ejectas come out. It's going behind Jupiter there, so Jupiter casts its shadow on Ganymede. I've seen that happen. It's pretty neat to watch. So there it goes. Beautiful. Makes me feel like we got ripped off on our moon, don't you think? Because they're so colorful. Our moon is very gray, but these are so colorful and pretty. Ganymede is actually 50% larger than our moon. In fact, it's even bigger than the planet Mercury. But because it orbits Jupiter, it's a moon. If we could separate it from Jupiter, it would be classified as a planet, to be sure. So that's Ganymede. And then the outermost of the big 4 is Callisto. There's Callisto. And there it is. Pockmarked with little white craters all over its surface. Quite fascinating. Isn't that neat? So those are the large 4 moons of Jupiter. There are 4 very small moons. Slow down time a little bit. There's 4 very small moons that orbit even closer to Jupiter than those ones. But the big 4 and those inner moons all orbit in the same direction and in the same plane. And again, I'm going to suggest that's a design feature. There's not a lot of space available there They orbit so close to Jupiter that if they had different orbits or orbited in different directions, the gravitational tug of one moon might eventually kick out another moon, cause it to be unstable. So moons that orbit close to their planet generally orbit in the same direction and in the same plane. Outer moons do not. There's the outer moons of Jupiter, some of them, yeah. And if I speed up time, you can see the inner moons are orbiting counterclockwise. The outer moons, a lot of them orbit backwards. Some of those could be captured asteroids in the course of the 6,000 years in which Jupiter's been orbiting the sun. Some of those could be captured gravitationally. That is possible. Or some of them might be original as well. And they're not even in the same plane as well. If I turn the system edge on, you can see, yeah, they don't even orbit in the same plane. They kind of do what they want. And it looks very crowded because the lines are thick, but there's actually a lot of space available. There's millions of miles available out there between these moons, and they're low mass, so they don't have much gravity. So there's no chance of collision or a gravitational disturbance. So outer moons kind of do what they want. And that's a common feature of the solar system. We'll see that with the other planets as well. So next planet out, Saturn, just about everybody's favorite, right? Other than the Earth. I'm real partial to the Earth. But Saturn is so stunning. Let me show you the way it is today. There's Saturn, and the Lord was kind enough to tilt that planet, I forget the exact amount, 28 degrees, something like that, so that we could see those beautiful rings. The rings are trillions of tiny little moonlets that orbit around Saturn's equator. Little pieces of ice and rock that orbit around Saturn's equator, trillions of them. And the planet itself is similar to Jupiter, just a little smaller. It's about 9 Earths across. Less massive than Jupiter, significantly less massive than Jupiter. But the Lord was kind enough to tilt that planet and the rings, which orbit around the equator, because if he didn't, you'd never know that they were there. Yeah, rings, they're hundreds of thousands of miles long. They're only a couple miles thick. So, yeah, pretty neat. There's a famous picture of Saturn that looks something like that. You may have seen that picture where Saturn's in a crescent phase. I don't think people realize the amazing significance of that, because it's proof that we've been there. The only way to see a planet or a moon in crescent phase is to be farther away from the sun than the object is. But Earth's never farther away from the sun than Saturn. Saturn is 10 times farther from the sun than Earth is. You can't see Saturn in a crescent phase from Earth. You can only see it from a spacecraft that's traveled there and past Saturn. So it's a really neat picture, a really neat image. So some interesting things about Saturn. Saturn has internal heat, like Jupiter, but secularists claim they have an answer for Saturn. They don't really have a good one for Jupiter. They claim they have an answer for Saturn with helium settling. So I don't tend to use that as an argument. But it does have a strong magnetic field, and that is just so hard to explain from a secular perspective. A lot of planets do. We've already talked about Mercury. We've talked about Earth having a magnetic field. Jupiter and Saturn, very powerful magnetic field. And secularists believe that these magnetic fields, because they know they're decaying, we can measure that on Earth. They believe there must be a recharging mechanism that kicks in over time, which they call a magnetic dynamo. And it has its problems. It requires the rotation axis to be aligned with the magnetic field axis. Earth's is not. It's 8 degrees off. We'll see with Uranus and Neptune, they're way off. So I don't think that's a good model, but I just wanted you to be aware of that they do have an explanation for that. Saturn has a number of interesting moons. We won't do all of them because I think it's over 100 now. But Mimas, one of the ones that orbits really close to Saturn, it's fun to look at. And I need to get a better map of it because there's an enormous crater on one side. You can see it there. And when the light hits it just right, it looks just like the Death Star from the Star Wars movies. It really does. It's just neat to see. So there's little Mimas. Let me back out a little bit. Two moons that are really interesting. Let's see if I can do this. I don't normally do this in this presentation, but I think we have some creation groupies here. So I want to see if I can do the moons Janus and Epimetheus. See if I can, is it going to do it? Yeah, there it is. So there are Janus and Epimetheus are these two, they're very small moons that they orbit at almost the same distance from Saturn. Now, as you know, planets or moons that orbit closer orbit faster, and those that orbit farther away orbit slower. Let me show you this. There we go. So if we speed up time, sure enough, the moons that orbit closer orbit quicker. compare that to Titan, which is quite a bit further away, and you can see it orbits quite slowly. Okay? Now, the neat thing about Janus and Epimetheus, their orbits are almost the same distance, but one of them is just a little bit closer to Saturn, and therefore it orbits a little bit quicker than the other one. But the problem is the distance between their two orbits is less than the diameter of either moon. Okay, think about that. The distance between their orbits is less than the size of either moon. So one moon has to orbit faster. Eventually, it's going to catch up to the other moon, and there's not enough space for it to pass. And this was really perplexing to astronomers when this was discovered. Because even if you started the inner moon ahead of the outer one, in 4 years, it will have caught up and should collide. But they're still there. How does that happen? Let me show you this. It's pretty neat. I'm going to center it. What I'm doing is I'm rotating the camera at the same rate that Janus and Epimetheus orbit, if I did that right. So, okay, I did not do that right. How did I not do that right? I'm centered on him, right? Oh, wait. It'll be worth it. Okay, let's try that. Well, that's still not working. That's so weird. Try it one more time. Select object, genus. Okay, let's try that again. Yeah, I don't know why that's not working. Well, that's just going to make us all sick, so that's not going to work. Yeah, I'm sorry I can't simulate that. I'm not sure why it's working properly. But the answer to the question, I was going to show it to you, but it's not working the way I wanted it to, is the answer to the question is when the inner moon approaches the outer moon and is about ready to collide with it, the gravity from the outer moon pulls forward on it, and the gravity from the inner moon pulls back on this one, which causes them to swap orbits. So then the outer moon is now on the inside track and ahead of the other moon and moves away from it. Every 4 years, these two moons swap orbits. It's beautiful. It's amazing to see. I'm sorry I can't simulate it, but really interesting. But there are plenty of other interesting moons. But as far as we know, that's the only place that happens, where you have two moons that swap orbits every 4 years. It's just remarkable. Titan is Saturn's largest moon, and it is a distinct, thick orange color. You can always see this, in even a Walmart telescope could pick this one out. Let's put it that way. You look at Saturn, you'll always see a little orange star next to it. That's Titan. And that's what it looks like because it's got a thick atmosphere, which is very rare. Moons usually don't have an atmosphere at all, and if they do, it's very thin. But not Titan. It's got a thick atmosphere made up of nitrogen, but the color comes from hydrocarbons. So gasoline is a hydrocarbon. So gasoline would be very cheap on Titan. On the other hand, oxygen would be expensive, so there you go. Count your blessings. So isn't that interesting? And it's caused by the breakdown of methane. Methane is a hydrocarbon, and when it's exposed to ultraviolet light, it produces tholins, and that gives you that orange color. So, and that's what you get after 6,000 years of exposure. Secularists expected there should be no methane left on Titan, because methane is destroyed by ultraviolet light from the sun. And if it were 4.5 billion years old, there should be no methane left. So they were astonished to find that there is copious amounts of methane on Titan. In fact, it's got seas of liquid methane on its surface. Isn't that interesting? So God does what he wants. We can penetrate that atmosphere because the Cassini spacecraft was equipped with a radar that can go through clouds, and so we know the surface of Titan looks something like that. That's what it looks like without that thick atmosphere. Pretty neat. The atmosphere makes Titan look a little bigger than it really is, like a cat when they get upset and they puff out a little bit. It does that too. And for a while, they thought it was the largest moon, but the atmosphere was cheating a little bit. So there you go. Another moon that's really fun is called Iapetus, and it orbits out further than Titan. Iapetus is interesting because when it was first discovered, it was on the right side of Saturn. It's kind of a snow, ice-covered moon, right? When it was on the right side of Saturn, it was discovered, and as they followed it around, they found that it disappeared. They couldn't see it when it was on the left side of Saturn. And then a little while later, it reappeared on the right side of Saturn and then disappeared. You can't see it when it's on the left side. And I forget who it was. It might have been Huygens. It was either Huygens or Cassini that figured out the explanation. They figured this moon, like all large moons, keeps its same face pointed toward its planet as it orbits. So when it's on the right side of Saturn, you're seeing one side. When it's on the other side of Saturn, you're seeing the other side. What if one side is really bright and the other side is really dark? It'd be hard to see on the other side. And that's exactly right. And so as we watch this thing rotate around, one side's as bright as snow, the other side is as dark as charcoal. Isn't that neat? And we think that's because one of the other moons that's beyond it, Phoebe, ejects sort of this dark material that collects on the leading hemisphere of little Iapetus. So that's what causes it to do that. Really interesting. It also has a string of mountains exactly along its equator, which is just wild. It's almost like God took this thing and just kind of pushed down on it like that, and the equator bulged out. But you can see that right there. You can see that? And it goes more than halfway around the moon, I believe. You can't see it here, but then when it comes around, you'll start to see it on the dark side there. Look at that. Look at that mountain chain right there, right along the equator. So we're not sure why that is that way, but it's neat. It's just cool. So Iapetus has a dark side and a bright side, just like the Force or an Oreo cookie. So there you go. So that's the Saturn system. The outer moons, again, the outer moons kind of do what they want, just like the moons around Jupiter. They're not in any particular plane. They're not in any particular. Now, each moon has its own perfectly good elliptical orbit. It's just they're all oriented differently. So that's the Saturn system. Now, a wonderful thing happened back in the 1980s. The outer planets, Jupiter, Saturn, Uranus, and Neptune, lined up in this giant arc, which made it possible for us to send one spacecraft past all of them. Really neat. The Lord was very kind to do that for us. And it really was an act of divine providence, because that doesn't happen very often. Every few centuries that'll happen. But they have to be in that arc, and of course you have to take into consideration they're moving as the probe goes out. But NASA figured they could send one spacecraft, the Voyager 2 spacecraft, past Jupiter, then use its gravity to slingshot it onto Saturn, use its gravity to slingshot it onto Uranus, use its gravity to slingshot it onto Neptune. And Pluto was a planet back then, but it was not part of the arc. So it ends with Neptune. So we were able to see the planet Uranus back in 1986. Was the first time we got close-up images of the planet Uranus. And it is a beautiful blue sphere, pretty featureless. Now we know from Hubble we have pretty good ground-based telescopes now. We know that Uranus sometimes develops beautiful white clouds, sometimes thick, sometimes looks almost like a polar ice cap that develop over the poles, sometimes. But back in January of 1986, it was a sunny day on Uranus. So very few clouds. That beautiful blue color caused by Rayleigh scattering, primarily from methane. That's one of the chemicals in Uranus's atmosphere. Uranus is tilted on its side. It just really has the secularists scratching their heads. So it rotates this way. It rolls around the sun. It's kind of neat. And the moons do that too. Its moons orbit around its equator, the inner moons anyway. All inner moons do that. They orbit, those that orbit close to the planet, that's a design feature. 5 moons that we knew about when I was a kid, now we've discovered another 20 or so. Miranda is the innermost of the 5. And the only one I've not been able to see in my telescope. The other 4 I've been able to see them. They're very faint, but Miranda's smaller than the other 4, so I've never been able to clearly see it. But really interesting little moon. The planet Uranus has a magnetic field that was predicted by Russ Humphreys, who is a biblical creationist and a physicist. And back in the early 80s, based on its biblical age of 6,000 years, Russ was able to calculate the magnetic strength. He says after 6,000 years, it should have decayed to this amount. This should be the magnetic strength. And the secularists thought, well, it should be magnetically dead. It's billions of years old. They were wrong. Russ Humphreys was right. That was confirmed in 86 when Voyager flew past it and measured that magnetic field. Isn't that neat? If you want to get the right answer, start with the Bible. It really helps. The next planet out would be Neptune. And we got to see, you can see the arc there. So we're still in 86 there. So Saturn, Uranus, and Neptune. Jupiter's moved on. So in 89 then, Voyager 2 flew past Neptune. And we got to see what it looked like for the first time. And I really love Neptune. It's a beautiful planet. It's beautiful blue. And it has little white clouds that develop and stretch around it. They don't quite form complete belts and zones like on Jupiter, but they still tend to be stretched out due to the jet streams. And it has a great dark spot, which we call the Great Dark Spot. Yeah, there it is. That's pretty neat because before that, only Jupiter had one of these storms, but we now know they form on Neptune as well. And unlike Jupiter, it's a low pressure system. It's a traditional hurricane on Neptune. And unlike the red spot, this one comes and goes. Sometimes it's there, sometimes it's not. Now, it could be that the storm is still there, but it's just changed color to where it blends in with the rest of the planet. There's also another one that forms in the northern hemisphere. Hubble has seen that. So it has at least two spots. We've never seen them both at the same time, however. So there's Neptune, about 4 times the size of the Earth, same as Uranus, and has that magnetic field that was, again, predicted accurately by Dr. Russ Humphreys, based on the biblical age of 6,000 years. And again, I have to remind you that secularists believe that magnetic fields recharge themselves with a magnetic dynamo. It's kind of like how the way the alternator in your car charges the battery. It takes physical motion and charges the battery. But that theory requires that the magnetic field be lined with the rotation axis, and it's not on Neptune nor on Uranus. They're very different. So that model doesn't work very well. Neptune has a bunch of moons. When I was a kid, it had 2 moons, and so those are the only ones I remember. And the larger of them is called Triton, not to be confused with Titan. Titan orbits Saturn, Triton orbits Neptune. Triton orbits backwards. It's the only large moon that orbits backwards, and it's not that large. It's not as big as our moon. But there's Triton. And by the way, if it looks blurry like that, that means the spacecraft was far away when it imaged that side. And then as it gets closer and it rotates around, we get clearer images of this side. Triton has a very thin atmosphere. And it has these dark features on it they're actually geysers, where it ejects soot up into the thin atmosphere, and then the prevailing winds carry it in an east-west trajectory. So they form these little horizontal lines. You can see them there, these little horizontal lines. Those are geysers. Isn't that wild? Now, in order to have geysers, you have to have internal heat. But this thing is much smaller than the moon, and it's out 3 billion miles in space. How does it still have internal heat like that? Because it's not billions of years old. It's a few thousand years old. So this was very shocking to the secularists, almost a controversy really as to how that could possibly happen. Pretty neat. A lot of stuff like that. We're just scratching the surface. A lot of stuff like that. So that's the Neptune system. And we've discovered a lot more of its moons since then as well. Okay. Well, when I was a kid, Pluto was a planet. So we're going to go there too, okay? Pluto was discovered in 1930 by Clyde Tombaugh. And we thought when it was first discovered, it might be as big as the Earth. And it was really hard to tell because it's so far away, you can't see any size to it. And then as we did, you have to make some guesses about how reflective it is. And as we made better and better measurements of it, we realized it's quite a bit smaller than Earth, maybe smaller than Mars, and then finally smaller than Mercury, and eventually smaller than the moon. Pluto is only 2/3 the size of Earth's moon. It's small. And we started finding other objects at about that distance, some of which were almost as big as Pluto, and one of which at the time we thought was bigger. And so then the question became, well, what do we do with these other 20 or so objects? I mean, if Pluto's a planet, and there's another one that's bigger than that, we need to add that one at least. Then what about these other ones that are almost as big? Should we add another 20 planets to our solar system? Well, think of the children. They got to memorize this stuff, right? So it was easier just to say, you know what, let's kick out Pluto. And we've now reclassified it as a dwarf planet. And I didn't know what it looked like, and nobody did until 2015, when the New Horizons spacecraft, which was launched in 2006, and took 9 years, as fast as we can get it out there, it took 9 years to reach Pluto. And I'm so glad they did it. It's been a very successful mission. One of the reasons we wanted to get it out there quick, Pluto is weird because it has an atmosphere sometimes. How does that work? Pluto has an elliptical orbit, more so than any of the planets. So in fact, sometimes it comes a little closer to the sun than Neptune. It did that between 1979 and 1999. It was closer to the sun than Neptune. When it's close enough to the sun like that, the sun can heat up the volatiles and produce a little bit of an atmosphere. But once it gets far away, that atmosphere freezes back to the surface. So it has an atmosphere sometimes. And we wanted to see it while it still had an atmosphere, which we did. We were successful in that. So that's what Pluto looked like when New Horizons flew past it back in 2015. And that was an exciting time. I was like a kid in a candy store. I finally got to see it. So that's what it looks like. And it's very surprising because the secularists thought, well, this little world out there, I mean, it's over 3 billion miles away from the sun. That's at its closest point. It gets out quite a bit further than that. So it shouldn't have much internal heat. And it's small. It's only 2/3 the size of Earth's moon. So it can't have any internal heat it had at creation or at its formation would have been exhausted a long time ago. And there's lots of other stuff out orbiting at that distance that should have hit it over billions of years. It ought to be completely covered with craters. Any initial mountains it had should have been wiped out by craters billions of years ago. And so it was very surprising to them to find, yes, there are some craters. In 6,000 years, it's accumulated some craters. You can see, there's a good one right there. It's a nice big one right there. But there are some areas of Pluto that have no craters. This area right here has no craters. We call this Tombaugh Regio after Pluto's discoverer, Clyde Tombaugh. Isn't that interesting? It has no craters in it. And it has this polygonal pattern like a jigsaw puzzle that you might see there. We think that was liquid at one point. It was like a convection cell pattern that froze in, which means Pluto had internal heat. And it had to have been relatively recently. It can't have been billions of years ago or craters would have formed since then. You see, it has to be recent. Pluto has other features that require internal heat, like mountains. There's little things that you see there. Those are mountains. Let me see. There's some big ones down here. Some of these are as large as the Rocky Mountains in Colorado. They're enormous. The fact you can see them from space tells you that. Pretty amazing. They're made of ice, though, instead of rock. At that distance, ice is as hard as rock. And they're covered with a thin layer of methane and tholins. It's the same thing that gives Titan its orange color. So Pluto is a little bit orange in nature. There are canyons as well. Look at that canyon over there on the right, that big feature there. That requires geology. That requires internal heat, and that means Pluto cannot be billions of years old. It can't be billions of years old. It's an evidence of the youth of this dwarf planet. Pluto has a large moon called Charon. It's actually got 5 moons, but one of them's big, half the size of Pluto. It's called Charon, and there's Charon. And likewise, Charon has all these interesting features on its surface. It's got mountains and valleys and canyons. It's got a dark North Pole, which we still don't understand what's causing that. But isn't that wonderful? That's an indication it can't be billions of years old. A lot of stuff like that in our solar system. And I think I'll show you this too. This is kind of fun. They've actually started naming these features, the people who, in the New Horizons team, and for the first time, they named them after sci-fi characters. I approve. I'm a sci-fi guy. So you got Vulcan Planum, you got Kirk Crater, you got Spock Crater. How about that? Sulu Crater. Star Wars is not to be undone. There's Skywalker Crater, Leia. Vader Crater. Ripley Crater from the Aliens series. Mordor is this area, so Lord of the Rings was also shown. I don't know if those will stick, but I approve. I hope they do. I don't know if the International Astronomical Union will recognize those, but in my heart, they will always be those names. So there you go. Now, everything we looked at today, we've looked at 8 planets, 1 dwarf planet, and their moons. And we've seen that they declare God's glory, not a nebular collapse. We've seen all kinds of evidence that's inconsistent with that. So of these 8 planets, I mean, it's interesting because back when I was in school, up until 95, these were the only planets we knew about. But we've now found planets orbiting other stars. We've discovered over 5,000 of them. And that's just the beginning. Right now, only a few of them have been directly imaged. Most of them, they pass in front of their star and they cast a shadow, and we monitor the stars light drop. That's how we know they're there. That only works for solar systems that are edge-on relative to ours. Think of how many are not. There's only been a very few that we've directly imaged. And there have been some. I've seen images of planets orbiting another star, 4 planets orbiting another star. It's cool. And if you think about it, that's what the ancients knew about our solar system. They knew that there were 5 points that moved, 5 stars that moved. That's all they knew about them. They didn't know that Saturn had rings or Jupiter had a red spot. They knew that there were 5 stars that moved. That's our knowledge now of other solar systems, 4 spots that move. And what that means is somebody in the future, 100 years from now, we might know as much about those solar systems as we do about ours today. Somebody 100 years from now could do a talk, could pick any one of these other 1,000 solar systems that are out there and talk about each of the planets of that system and how they declare God's glory and how they refute the millions of years and so on, if that's even a belief at that time. Isn't that amazing? God is glorious. And yet for all the planets that exist out there, and there again are over 5,000, this is the one that God visited. This is the one where God sent his son to die your death. Because you're a sinner, you're a wicked sinner. We all are. And God can't let us into that new heavens and new earth that are going to reign perfect forever, or our sin would corrupt them the way we did the original. And so he provided a way of escape. And that happened all on this little gem where God placed those creatures that he made in his own image. And so that's a beautiful reminder of the gospel. One of the astronauts who walked on the moon, Jim Irwin, he later became a Christian and a biblical creationist, by the way. And he said something once that really struck me, and I'm paraphrasing, but he said something to the effect of, the amazing thing is not that man walked on the moon, but that God walked on the earth. And I think that's true. So that's the point I want to leave you with this evening. Let me show you some of the resources that we have. My latest book, The Importance of Genesis, shows you why Christian doctrines are rooted back in Genesis and the literal history of in Genesis, why that matters. Why that matters. You want a little more in depth on that, understanding Genesis. I won't go through all these, but I will remind you of the ones that on astronomy, Stargazer's Guide to the Night Sky, if you want to know how to see some of the things we talked about tonight, it's in that book. And the constellations, if you want to get a telescope, what kind you might want to get, how to use it, how to look for details on things like Saturn and so on. That's a fun resource. Just how to enjoy the night sky from a Christian perspective. If you want more of an apologetics book, this is the one you're going to want to get, Taking Back Astronomy. And that's going to show you some of the evidences we covered today about how the internal heat and the magnetic fields of the planets are inconsistent with billions of years. Physics of Einstein, if you've ever wondered about what about time travel and black holes and what about distant starlight, all answered in that book. Written at a layman level, but with in-depth boxes for students who want to go into more depth on that. Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. You've heard the critics say you can't trust the Bible because this verse contradicts that one. It doesn't. I checked, and I wrote a book responding to that, so you can check that out. Introduction to Logic, How to Use Your Mind Rightly into the Glory of God. That's a lost skill in our culture, so I'm hoping people will pick that up. It really shows you that thinking rightly is to think in a way that's consistent with God's character, and it really is. We have a teacher guide for that, too, if you want to use it with your students. It's got tests and quizzes on it. And I went through my own book with my home church in our Sunday school class, and we recorded those 10 sessions on logic, going through that book for our audio-visual learners. That's our Get Logical series. I won't go through all of these. I will remind, this presentation, by the way, we have it on DVD, and I never do it exactly the same way twice. I don't have any notes for this. I just get up here and pontificate, so I hope it was somewhat sensible anyway. But it's just so cool. There's so much to learn about our solar system. Secret Code of Creation, showing how God has built incredible beauty into an aspect of creation that most people never even think about. And it is so cool. And in fact, if I'm not mistaken, the first time I gave that presentation was here. So, yeah. So we now have that on DVD. I've improved it a little bit since then. So you got to burn your old version and get the new one. And we have that on Blu-ray as well. And I now have a book on that topic called Fractals, The Secret Code of Creation. You might leaf through that book. Every picture you see there was not drawn by a human being. It's artwork of God, and there's no secular explanation for it. It's really stunning. You can get the best of our books together for a 20% discount tonight only. We don't do the packs on the website. DVD, the best of our DVDs for 20% discount, or our library pack, the best of the books and the DVDs for a 30% discount tonight only. We do have a few other packs too. We have an astronomy pack if you wanted to look into that. We have that as well. And sign up for our free monthly newsletter. It is free. We just want to bless you. So make sure you put your email address, though. If you don't put your email address, you'll get nothing because it's an electronic newsletter. Okay, it comes in your email and only in your email. So make sure you sign up for that. We just want to bless you. Not too many things free in this world, just salvation in our newsletter. So check that out. And we have some books too from Master Books, our publishing company, on Noah's Ark and on dragons, dinosaurs. Those are great resources that I encourage you to check out. And then check us out as well on the web at biblicalscienceinstitute.com. I think our worship team is going to come at this time. And I'm going to go ahead and close in prayer. After we do a song, you're going to have an opportunity to go out and buy some of those resources. I encourage you to get those. Then after that, if you want to, you can come back and we'll do a Q&A session. But this will be your last opportunity to buy books is after this worship song, okay? Because our team was going to be packing up during the Q&A session. So let's go ahead and close in a quick word of prayer. Heavenly Father, we thank you so much for this time. We thank you for the beauty you've poured into your solar system. These are your worlds, Lord. They're worlds of creation. We thank you for their beauty. We thank you that they declare your glory and confirm biblical creation. And I pray this message is encouraging and encourages us to share our faith with others. And we ask this all in Jesus' name. Amen. Thank you.